Okay, in this mini lecture, what we're going to do is just have a brief introduction to what I see as the three primary elements to Chapter 7. And then we're going to go over what I think is an important numerical example to show, to show how Chapter 7 builds on Chapter 6. So let's first take Chapter 7 and break it down into three parts. The first part is sampling methods. That's actually section 7.1 in the book. And then I think sections 7.2 captures both the central limit theorem and what I call calculating the probability of a sample occurring rather than calculating the probability of a single occurrence. And really what happens is in chapter 6 you learn how to calculate the probability of a single occurrence. What's the probability of one person having an IQ of at least 125? What's the probability of one person having an IQ of less than 90? Well, what we do in chapter 7 is we extend this and we say, and we calculate what's the probability of a sample having, let's say, an average IQ of 125. What's the probability of a sample having an IQ of less than 90? Okay, so just in terminology, the central limit theorem qualifies as hugely important. This section in chapter 7 on doing the z calculations on a sample rather than a single observation, that qualifies as hugely important too. So what I'm going to do in the rest of this video is I'm going to go through a numerical example of what shows here in the third item. Okay, so let me first take you back to chapter 6. And we worked with, I think these numbers come exactly from chapter 6. We calculated what was the probability of one person having an IQ of at least 125, given that the mean IQ is 100 and the standard deviation is 16. I'm not going to take you through the arithmetic here. I think you're able to do that by now. But if you'll recall, when we calculated the probability of one person having an IQ of at least 125, ended up that IQ is about 0.06. Okay, so 6 people, 6 people out of 100, 3 people out of 50 would have an IQ of 125 or more. Okay, not a frequently occurring item, but at least it, we can. There's a calculable probability that it does happen. Now I move you from chapter 6 to chapter 7, and look how the question changes. In chapter 6, I asked the question, what's the probability of one person having an IQ of at least 125? Now in chapter 7, we ask the question, what's the probability that a sample of 16 people, and you'll see momentarily why I picked the number 16, what's the probability that a sample of 16 people would have a mean IQ of at least 125? Okay? Now, if you look in the textbook, you'll see the formula for the z-value. I just went directly here and put the numbers in. But I want to compare this set of numbers to the numbers up here from chapter 6. Notice how our numerator is the same. In chapter 6, our numerator was 125, the targeted IQ, minus 100, the population mean IQ. Down here, the numerator is the same. The targeted IQ is 125. The mean IQ is 100. But look what happens in the denominator. Up here, we just divide by the standard deviation. When we're working with a sample, we divide by the standard deviation divided by the square root of the sample size. And that's why I picked the number 16. The square root of 16 obviously is 4. So rather than our denominator in chapter 7, rather than our denominator being 16, it's 16 divided by 4, the square root of 16. 16 divided by 4 is 4. So whereas here in chapter 6, our z-value is 1.56, which was just 25 divided by 16. In chapter 7, because we're working with a sample, our z-value calculation is 25 divided by 4, which is 6.1. And if you look up in the z-table on page 375, you'll find that the z-table doesn't even go up to 6. Okay, I think it stops at 4. So the probability of, if indeed the average population mean for IQ is 100, and if indeed the population standard deviation is 16, the odds of taking a random sample of 16 people and their average IQ being at least 125 is so remote that the p-value equals 0.000. In other words, it's virtually not non-existent to happen with a sample of 16 people. Now, one person in our sample of 16, there's a 6% likelihood, or a 0.06 probability that one person in our group, in our sample of 16, would have an IQ of greater than 125. But the larger your sample, the more compressed the distribution becomes, and the way the distribution becomes more compressed is your denominator gets obviously smaller and smaller. So that's a quick introduction to Chapter 17. We'll spend quite a bit of time on Chapters 7 on Friday the 10th of February and Monday, February 13th. So if you're confused at this point, we'll have you unconfused just in a few days. Thanks.